to projects. In this video, we will explain self-paced deep learning for weakly supervised object detection. Introduction: addressing the problem of weakly supervised object detection in computer vision in the absence of precise bounding box annotations, iterative procedures used in current systems that can create errors, particularly with initial classifiers. To address this, a unique self-paced learning technique that selects reliable subsets of images and boxes for iterative training is introduced. The project intends to outperform weakly supervised approaches, including those with more sophisticated networks, by leveraging the AlexNet model trained on the IRS VRC dataset. Coming to objective, the project's goal is to create and test the efficiency of a self-paced learning system for weakly supervised object detection using deep learning techniques. The project intends to address the shortcomings of existing iterative approaches by developing a training protocol that gradually refines the learning process. The project aims to achieve improved object detection performance by exploiting the AlexNet model trained on the IRS VRC dataset, outperforming weakly supervised algorithms and even those based on more complicated networks. These are the requirements for execution of the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, and hard disk of 20 GB and above are required. In software requirements, Python IDE of 3.7 version is needed. These are the design modules in the methodology for execution of the project. First one is generate and load self-paced AlexNet model. AlexNet is a landmark convolutional neural network architecture introduced in 2012. It plays a crucial role in popularizing deep neural network of computer vision tasks. With its deep structure, ReLU activation, max pooling, and large-scale training on GPUs, AlexNet achieved breakthrough results in image classification tasks, setting the stage for the development of modern CNN architectures. This module involves the creation and loading of the self-paced AlexNet model. The process likely includes the following steps, which are: the AlexNet architecture is initiated possibly using a deep learning framework like TensorFlow or PyTorch. This self-paced learning strategy is applied here. The model starts by training on simpler objects or images with lower complexity. The training data is gradually adjusted to include more complex objects as the model's performance improves. The model is trained on the provided ImageNet dataset using a loss function appropriate for object detection, which may involve bounding box prediction and class probabilities. After training the model, it is serialized and saved to a file so that it can be loaded later without retraining. Next one is upload test image. In this module, we will upload an image that they want to perform object detection on. The uploaded image will be pre-processed to match the format and size expected by the trained model. This could involve resizing, normalization, and other transformations. Third module is run object detection. This module is responsible for using the trained model to perform object detection on uploaded test dataset. The uploaded image is fed through the loaded AlexNet model layers to obtain feature maps and predictions. The model's predictions are used to identify potential object locations in the image. The model predicts bounding box by coordinating for each detected object. The model predicts the class or label of each detected object. The model's predictions are used to draw bounding boxes around detected object on the test images. The bounding box might also include the model's prediction probabilities. For execution of the project, first we need to open the code folder. This is the code folder of the project, and this is the AlexNet model. It contains the algorithm information. This will be loaded into the project code during runtime to train the model. And these are the images. On these two images we will be training the model. And this is the Python main code file. And this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So we need to double click on it for execution. This is the graphical user interface of the project. With this, we will be interacting with the program, and this is created by using Tkinter library. So first we need to generate and load the model. So for that, we need to click on the button generate and load self-paced AlexNet model. So here it is showing the confirmation that AlexNet object detection model is loaded. Now we need to click on the button OK. Now we will be uploading the test image to detect the image. So here I will select this image and click on open. Here it is showing the confirmation that image file is loaded. Now we'll click on the button OK. Now we will click on the button Run Object Detection to detect the image. So here, model detected different objects from the image and then identified those objects and surrounded them with the bounding box with prediction probability. So here, it has detected 3 objects which are dog, person and other person. For this dog, here is the probability, and for this here we have the probabilities. Now we'll check with the other image also. So here, aeroplane is detected with bounding box, and also birds are also detected with bounding box. Here are the probabilities of aeroplane and the birds. Now we will exit this GUI. Conclusion: presenting a pioneer solution for weakly supervised object detection leveraging a novel self-paced learning approach, the project demonstrates the AlexNet model's capacity to outperform a complex network-based approaches by training it on the IRS VRC dataset. The successful incorporation of self-paced learning into deep neural network not only improving accuracy and dependability but also highlights modern architecture versatility. This accomplishment has broad implications for computer vision applications, providing a potential method for addressing issues in supervised, unsupervised circumstances. Essentially, the project highlights the dynamic potential of deep learning approaches in creating the landscape of complicated problems in computer vision.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.